Hello, research design and analysis students. Dr. Wickline here today to walk you through doing step 2 of hypothesis testing, which is setting your boundaries. So I'm going to use the example today of a t-test. We would actually set the boundaries for whatever hypothesis test we're doing, whether it's a z-test, a correlation, ANOVA, t-test. But in today's example, I'm going to demonstrate with a t-test analysis, which is used to compare two groups on one outcome. So we're looking for potential differences in those two groups for our dependent variable. I'm going to zip up here in the side so that I can give you the sample document we're working through today. So let's say we had a hypothesis that girls would have different levels of verbal aggression than boys. Anybody who survived middle school knows that boys and girls both do aggression, but they tend to handle it differently. Now, that doesn't mean we stereotype and think all girls do it this way and all boys do it that way. But we might have, from observation or research, decided that this is a reasonable idea to test. Mathematically, what we also do is suggest what our null hypothesis is, that nothing's going on, that there is no difference. And this is what we use when we're doing a t-test or some other thing. We expect most of the time that a difference won't be shown. So if a value comes out high, far away from zero, it suggests to us that there might be a phenomenon in the real world that actually is showing a difference. Mathematically, what we're doing here is saying the mean for group 1 is no different than the mean for group 2. And if you're doing hypothesis testing for me, you should be showing your null and research hypotheses both in English and in that mathematical notation. Now, we tend in math to use the Greek letters instead of the English letters for something like this. And so I just want to type a little letter mu. Thank you very much. I'm going to type a small m, which stands for the mean, and I'm going to change it to symbol font. So, little trick there. You will tend to see, this is not going to be my day. You will tend to see sometimes these swoopy Greek letters instead of those letter m's here, but it's still suggesting that the mean for one group is the same as the group in our null hypothesis, and that those means are not the same in our research hypothesis. Okay? So first you set your idea, and then you have to go figure out what is the critical value that we find that's going to get us excited, that's going to have us suggest something is going on instead of nothing's happening. Well, setting our boundaries has two parts. First, we set our alpha level. And psychology most of the time uses 0.05 as a standard. We can use something more restringent or something more lax depending on our situation, but for beginners like you guys, 0.05 will suffice. What this alpha level means is we're willing to have a 5% chance of the results we find having been due to just like a fluke, that it's still something that could happen, but it doesn't really reflect what's going on in the real world. Any kind of inferential testing leaves us open to the possibility that the sample we find doesn't really reflect what's going on in the world. It's part of why we want a big sample. It's part of why we want to replicate studies to make sure that we're finding the same thing again and again, and we didn't just have some kind of fluke with the sample that we picked up. And this alpha level, 0.05, helps give us a really small chance of making the wrong kind of conclusion. Now, what we do then is find out what critical value for our inferential test goes along with that alpha level. And if we have a two-tailed test, something like this, where we're just looking for differences, we have to take that 0.05 alpha level and divide it by 2, because we want to look at a little bit of things here and a little bit of things here. So we're actually going to look up the probability of 0.025, and we're going to have two critical values. One up here that would show girls do more aggression than boys, and one down here that would show girls do less aggression than boys. Once we've set our alpha level, we can figure out our degrees of freedom, which is how many scores can vary, and we would still come up with the same means for each group. And so we need our alpha level and we need our degrees of freedom to go to a probability table and figure out how big that t value needs to be before we get excited, all right, or before we realize, hey, that seems to show a difference. So with a two-tailed test, again, we've got to divide that alpha level in half because we're looking for some t-scores up here and some down here. And your next step then is to go to some tables about probability. Now, your Privateera textbook has these in the back in Appendix C, or if you have a different stats book, I'm sure they're in the back of that too, or you can always Google t-distribution table, and you'll find ones online as well. So because we're doing a t-test in this example, I've got to go down through my appendix and find the table that's specifically for t-values. That one's not it yet. That one's Mann-Whitney. Where did you go? T-test, t-test, Spearman, Pearson, Q, F. Here we go. Critical values for the t-distribution. In Privateera, it's table C.2. Now, our degrees of freedom for an independent samples t-test like this, the girls are different than the boys, is going to be equal to the total sample size minus 2. So if we had 100 people in our data set, that would be 100 minus 2, or 98 degrees of freedom. If we had 30 people in our data set, it would be 30 minus 2 is 28 degrees of freedom. If we had 1,000 people in our data set, 1,000 minus 2 is 998. So what you try to do is look at the place where your degrees of freedom intersects with the probability that you have picked in advance and find out the t-value that goes along with it. So again, it matters whether you're doing a two-tailed test, just looking for a difference, or a one-tailed test, looking for that you expect one group to be bigger or smaller than the other. So I'm going to start with a two-tailed example. We are going in a two-tailed sample with 0.05 probability. Let's say that we had 12 degrees of freedom because there were 14 people in our data set. In that case, the t-value that we'd need for the proportion in two tails and 12 degrees of freedom would be 2.179. If we had a larger sample, looking at the next page of, say, 30 degrees of freedom with two tails, then our value would be 2.04. If you're working with a large data set, above 122 people, then you would use the line for infinity, and that 0.05 alpha level with infinity, anything above 120, would be 1.96. So what I'm going to put in on my document, assuming we had a large sample, in this case, is plus 1.96 or negative 1.96. That's the t-value of the large sample that we'd need to have for us to go, yep, those groups look really different. Okay, that's probably showing something meaningful. So please notice the value that you select is based on your sample size, minus 2, and whether you're doing one or two tails and what you set that alpha level at. Okay, so if you had, let's say, 32 degrees of freedom, there's no exact number for 32. You're going to have to bump it down to 30. Always go a little bit smaller than the degrees of freedom you have if you've got a number that's not represented in your table. Right? Now, let's say we thought the girls were going to have more verbal aggression than boys, and we were only interested then in a t-score where girls was higher. If that's the case, we're doing a one-tailed distribution. So let's assume again we had a lot of people, a couple hundred girls and boys in our study. In that case, we would still figure out our degrees of freedom, but we're only looking at the proportion in one tail. I think girls are going to be higher than boys, so I'm looking at one side of the distribution. In that case, if we go down with one tail and a large sample, the t-value that we'd need goes to 1.645. And in this case, we would be looking just at, that right side of the distribution, and we would need a value to have a positive value. If we thought boys were going to be more verbally aggressive than girls, we're still saying a direction, one-tailed, but we would be looking at the opposite side of the distribution. So please notice a couple of key things. You have to set your hypotheses first. You have to specify whether you're doing a two-tailed hypothesis that's just looking for difference, or a one-tailed hypothesis that specifies which direction the difference goes. And then you have to set your alpha level to figure out what that critical t-value is. Okay, and that depends on those choices you've made. So a two-tailed test will kind of take that alpha level and look for something on either side, giving you two critical values. Or if you specify a direction, you might be looking just for a negative t-value or a positive t-value as the thing that you're interested in. I hope this helps give you a walkthrough on how to set critical values for step 2 of hypothesis testing. Thanks, guys.